2.2, find slope and rate of change. This time it's going to be relationships of pairs of lines. Parallel lines, perpendicular lines, and then what's that special case? So first let's talk about parallel lines. They have the same slope. So if I look at a line with a slope of 3, right? Up 3 over 1, up 3 over 1. So there's one line. If a line is parallel to that, it's just going to end up being located differently. It's going to cross the y-intercept and the x-intercept, or y-axis and x-axis at a different point, but it's still going to be up 3 over 1, up 3 over 1. So those are two lines that happen to have the slope of 3. That's what makes it parallel. They both rise and run at the same rate. Think in terms of rate. That's where we're heading. Perpendicular lines, their slopes are opposite, meaning opposite sign. One's going to be positive, one's going to be negative, and reciprocals, right? Flipped over. So I'm just going to do a super quick sketch on this. Well, let's do this. What's the ultimate case, right? I'm trying to draw that. Let's do it a little better. Right through all of those diagonals, all of those diagonals, all of those diagonals. I'm not going to go all the way across the coordinate plane. My coordinate plane's too big, right? But I'm trying to go right across where all those, up 1 over 1, up 1 over 1. So there's a slope of 1. Well, if I change the sign and flip that over, then this one's going to be down 1 over 1, down 1 over 1, down 1 over 1, down 1 over 1. Slope of -1. And that's the one that people forget. So let's do a parallel, pretty easy. 2 and 2, 1/2 and 1/2. Perpendicular is the one that people struggle with a bit more. So let's look at some number cases here. If I have a slope of 2/3, then if I change the sign and flip it over, it's 3/2. That's going to make perpendicular lines. They meet in a right angle. Another example, what if I have a whole number? Well, I want the opposite reciprocal, so change the sign and then flip it over. Well, think about what's true about this 4 is it's really got a little invisible 1 under it. So if I flip that over, it's 1 over 4. So there again, I have two lines that meet in a right angle. They're perpendicular. The last thing I want to talk about is the special cases. So what if I have a line like this? Well, what's the slope of that line? It's 0. I can't make it negative. What line is perpendicular to that? A vertical line. So undefined, or vertical lines, and slopes of 0, horizontal lines, should be the easiest to think of as perpendicular, but sometimes people forget them. And recap, what's true about the slopes of parallel lines? What's true about the slopes of perpendicular lines? What are those special cases, right? Special case, those vertical and horizontal lines. Those are definitely perpendicular.